typical Swiss timing. We are really on time. This is Thomas again. I'd like to introduce to you Beda Hammerschmidt. Beda is working for Oracle Corporation, and he's not just working for Oracle in general, just to explain what Oracle is, but he's actually one of the guys who helps developing the Oracle database further. His topic is the representation of data, namely JSON and SOTA. And I was very much tempted to say, is that all? I mean, we've seen that. We've seen the development of DBAs. We've seen how security develops. Now we see how data representation changes. And it looks like this is something which we always do back to the theme, namely databases are developer tools. Having that in mind, Beda, what is it you can share with us on JSON and SOTA, and why is it good for developers, but also for other people out there like architects and for security guys? What's in for them? Stage is yours.
Great, thanks for the introduction. Yeah, let's have a little fun. I got some slides and more demos, so I tried to make it a little exciting for you. First of all, let's give some credits to our sponsors that make this event possible. Leave this on for a couple seconds and then let's get started. Right, as was already said in the introduction, I'm one of the people who developed that feature. It's not only that Oracle created some support for JSON that I will explain it, we also made sure that it became part of the Open SQL standard. So now we see a lot of other databases like Postgres, for example, or MySQL adopting some of these standardized functionalities. But it's still a work in progress. So the story with JSON is by far not over. It's very active. So let's jump right into it. So I assume that a lot of you already know what JSON is, but for those that are new, just listen for a minute or two and you are officially JSON experts. So what is JSON? So JSON is a way to represent your values, not in a table and in columns, but instead in such a string representation, which is like a hierarchical data model, similar to XML. We do have values like John or Smith, and these values are associated with a key. So we see, for example, John is the first name of a person or Smith is the last name. So we have a self-explaining data structure. And we also know the data type. So for example, John and Smith are in double quotes, whereas the age 25 is not in double quotes. That makes it a number. Or we have some special values like true and false and null. And those are these scalar values where the syntax defines the data type. It's very limited. Unfortunately, we don't have a date data type. So if you look at the bottom, at last updated, it looks like a string, but technically it looks like a date if you look at the content, but technically it is actually a string here. And then you build structures by combining or by adding these key value pairs into objects. So our entire data structure it's called a JSON object. And you can tell by looking at the first and the last character, like these curly brackets, that say everything that's inside are key value pairs. You see that you can nest these objects. So if you look at the value for address, that's not a scalar value, but it's an object itself. So the value is always followed by the colon. The colon separates the key address from the value, which is, in this case, is a nested JSON object again, meaning it contains key value pairs. And then the last data structure, it's also complex data structure, is the JSON array. So this is a list or an enumeration of values. So in this example, we have an array of phone numbers or of phone number objects because the content of this array are two objects. And again, these objects have these key value pairs, key type, value home, etc. So this is a data model that was introduced probably over a decade ago. And JSON is short for JavaScript Object Notation, and it basically gained popularity by JavaScript developers. So at some point, all the people who made static HTML pages had to learn some JavaScript to make these pages interactive. And as part of that, they got familiar with JSON. And JSON has also become like a very, very common, probably the de facto format to exchange messages between a web browser and a web server. So you may now ask yourself, this is a message format. This was never designed to be something you would store in the database. So why do we see so much popularity for JSON in the database, including now database aspects like indexing or queries, etc.? And we see many use cases by now. So JSON has been part of Oracle releases since 12.102. It was never a paid option. So if you had a database 12.102 or later, you always had access to these features. And by now we've seen like several hundreds of customers using it, and we assisted some of these customers to get the most out of Oracle. And by this, we learned a lot about common or why customers use this. And I summarized these 3 common use cases and why people choose JSON. And these are not ordered. These are just like 3 reasons without any priority. So the first reason is that with JSON, you avoid the normalization. So developers like to think in business objects. They may think I have something like a customer or a purchase order or a contract or something in my business domain. And I may express this using a Java class, for example. And now if it comes to the database, if I go relational, I typically normalize this and I map this one single business object to multiple tables. So for example, in this person use case, since a person could have multiple phone numbers, I may introduce a phone numbers table. So whenever I need to insert a new customer, I insert into the customer table and into the phone numbers table. So there is some complexity by this normalization or relational mapping. And with JSON, it's easy to go from your object representation in your programming language, let's say a Java object, to and from JSON. So this is a big ease of use, decoupling also your changes in the application from your database changes. We also seen some performance reasons. This was a bit surprising, as you may think, oh, JSON, it's a big data structure. It's probably making things slower. That may be true in some cases, but not in all. We had one major shipping company who replaced a normalized storage with, I think 12 tables or so with JSON. And they actually saw that for if you want to fetch like your shipping information, or if you want to put insert your shipping information, that actually by having it in one JSON document was actually a lot faster than having to go after multiple tables. Another use case is an insurance company which stores every insurance policy as a JSON. And you can imagine a life insurance looks different than a car insurance or liability insurance. So you have all these different schemas. And with JSON, you don't have to deal with like a complex normalization in the first place that is able to express all these different schemas, so to say. But most of these customers at some point have reporting or analytical query requirements. So not only do we want to be able to store your JSON, but we also want to make it accessible to your relational processing. And I have a slide on that later. The second big use case is schema flexibility. So in our example, where we start with a person having a first and a last name, we may realize if we go to the American market, for example, we also need a middle name. So it's a slight schema change. We're just adding an attribute. So in the relational world, this would be a alter table add column. That's typically not too bad unless you have a DBA who takes like 3 weeks to do this. And the other more severe schema change is a cardinality change. So maybe we realize after a while that a person could have multiple addresses, not only one. And now in the relational world, we could say, well, let's add more columns for these addresses, which make it hard to query. Or we say we just use a different table, like an address table, whereas in JSON, all you do is you convert your address, which used to be a nested object, into an array of nested objects. Again, we see a lot of customers using JSON as flex fields. So they store JSON alongside relational columns. So it's typically primarily, let's say, an 80% relational application. But then for flex fields, they say I add a JSON column in it. So they combine relational schema with JSON. Big Customer is a large stock exchange in the United States. They store financial like attributes or parameters for financial products. They have a choice of 1,600, so they ran into the 1,000 column limit. This is when they contacted us. And well, the initial problem was how do we get across, around the 1,000 column limit, and with JSON that was possible. But the other benefit they realized is that also the application is now in full control. So if the application decides we need to add another attribute, I don't know, like a new price finding algorithm or something like this, they can just inject that into the new JSON documents that are being generated, and no database change is needed. Again, here, there is a very strong reporting requirement in this use case. So we're going to see how we solve that. And the third use case, it's has a little bit to do with the first one, is also to get rid of SQL. So this is, or at least for simple operations, this is something that NoSQL databases, especially MongoDB, have introduced, where if you just want to do simple operation like insert a customer, find a customer, delete a customer, you don't want to write, they don't want to write like a SQL string, a SQL statement in a string, then have bind variables, prepare statement, execute, etc. Instead, just have a one-liner like put, get, find, etc. So it's the API. It's like a JSON or a document store API on top of the database. And this is what we solved with Soda. Good. So let's take a look here at, and I will show this more in demo, so I don't want to jump too deep into these slides here. One aspect is how do I store JSON in the first place? So it's not like a separate storage engine or anything else. It's just a column in your existing tables, for example. So here we use the employee table and we add a column called flex. And in the pre-20 versions, you would store a textual representation of your JSON, where you added this is JSON check constraint. So if you inserted something, it got validated that it is JSON. And later on, we introduced a JSON data type that uses a binary storage, and I will show this in a second live. So, and then if you insert your JSON, it's just provided as a string. It's being parsed, validated, and stored. And then you can just query it using SQL. So here we use the simple dots to just drill into the JSON. So for example, I can say dot skills or dot number patterns and extract values out of the JSON. Let's look at a very common operation that many customers use that is called JSON table. So I store my JSON in the database in a column. So here it's the example that I used to introduce JSON. And let's say this is stored in a column called JCall, and the table is called custdata for customer data. And I want to do some SQL analytics over it, or I want to join this with, let's say, a relational table. I basically want to have a relational view over this data. I want to see it as if it was a table. And what we have here is JSON table. It's in the from clause. We call it a row source. I don't think officially, but internally, because it generates rows and columns. So you pass your JSON value as input to JSON table, and then you list all the fields or all the columns that you want to extract from this JSON. So for example, we say, I want to have a column age. Its data type is a number, and the value is what you find if you walk this path expression, $.age. Dollar is just the placeholder for the current context. Has nothing to do with money. You don't have to pay Oracle any money to use JSON. It's free. It's basically saying, go to my document and go to the age field. Basically, this 25 is getting extracted, and you then see this as a column value in your table. Or for example, state, we're walking 2 steps, .address, .state. We first walk to the address object, and then inside we extract the value of the state. And then with JSON, you can have these nested collections or these JSON arrays, meaning that for one JSON document, you can have multiple embedded objects. And it's not only one array that's possible, you can have many arrays. Arrays can be nested. So this the structure can get arbitrarily complex. But what we can do with this nested path is we iterate over this collection. In this case, we're iterating over these phone numbers. So we say dot phone number, that gets us to the phone number array, and then square bracket, and the wildcard means select all of them or iterate over them. And we extract the value for the phone, the number value. And what you see here is, although we inputted just one value, one row into JSON table, we get 2 rows out because the 2 phone numbers in this JSON array generated basically these 2 rows, and the values for outside, they're getting repeated. And at this point, imagine you create a view with a statement. You can now run arbitrary SQL against this view as if it was a relational table. Good, so let's get to our first demo here. So I got my SQL developer here, and I'm running it against a database on Docker. It's actually a 21C here. This is a privilege of working for Oracle as a developer. I can get these daily builds as Docker images. So what we want to do is we want to show this JSON table live. And for this, I've downloaded a JSON data set from a machine learning website. So I inserted this using external table. Let me move my camera a bit so that I can better see my screen. So I inserted this JSON data that I downloaded and that I've not created. I don't know anything about it into my database. It's just one JSON record, but it's pretty big. It's 75 megabytes. So I could select it. And I see the first character here is a square bracket. So this looks like an array, like the collection or list of objects. And then I see that there are key value pairs inside. So it's a list of objects, but how would I know all the possible field names that exist in this record? Well, I could just select a random one using JSON query. That's one of these SQL JSON operators. I provided the input and say, well, select me one random object from this array. I get it back, but even if I look at this one, it's not very big. Let's just copy it and print it here. I get some field backs, but there is no guarantee that the field names that I'm seeing here is everything that's possible, because JSON is schema flexible. There could be more fields in here. So what I do instead is I run this JSON data guide. This scans the entirety of these 75 megabytes and gives me back a summary or a schema. And the 75 megabytes are now condensed to 88 lines. And it tells me, Beda, what you're looking at, it's actually an array. And inside that array, there are objects. And all the possible field names of these objects are listed here, even if they don't occur in each of them. If it occurs at least in one, it will be listed here. And not only does it tell me the name of these fields, it also tells me what data types they are, like winery would be a string, and what the maximum length would be. So it would fit in a 64 character wide string. So now I know a lot about my JSON, so I could start writing a JSON table statement, but why should I do that? I can automate it. So here what I'm doing is a little PL SQL. This is just the same data guide, the one where you see the results here. And all I do is I pass this data guide into this function, create view, DBMS JSON create view. I want to have a view called auto view over that table. So let's describe this view. And I see here that each of my JSON field names is now a column name. And if I do a DBMS metadata get DDL, let's just copy it in here just for, it's not a JSON, but what you see here, there is a JSON table statement, and all these path expressions and data types have been auto-generated. So now I could do the first thing. After I describe this view, I could do a count. So remember, it was just one JSON document, but it was 75 megabyte large. So I have 100 29,000 rows coming out of this view over this single JSON row. I could say, well, there was a field called country. Let's see what are all the countries in my data set. And well, you see there's like 40 countries or so. Is there Switzerland in there? There is. Let's see. Okay, now let's do something live here. Let's see how many we have from Switzerland. We do have 7. Okay, that's not that much. But let's do it anyway. So now I could do, see, I didn't know anything about my JSON. Like 2 minutes ago or 3 minutes ago, I just inserted it. I didn't know anything about it, but at this point, I'm already able to query it using this data guide generated view. So I know that my price range is from 21 euro or dollar to 160, and the quality measured in points goes from 83 to 90. Doesn't mean that the cheapest wine has the lowest quality or the lowest point. It's just like the range of both these values. So I certainly don't want to spend 160 on a bottle of wine, but let's find out if I at least want to have 90 points. Well, let's say 85. The example was for Chile. Now let's say 88. That's the minimum points I want to have. But let's say I want to order it by like the simple metrics. I want to basically maximize the points, minimize the price. So I got the result back, and actually the cheapest wine has 90 points, so I probably go with this one. But I prefer red anyways. So the point is, you have some JSON, and we make it very easy to access it relationally. So it's not really a JSON silo. Instead, it is really JSON and relational combined. And I've shown one direction here using JSON table. What about the other direction? So let's say I have a relational schema, maybe a legacy system, and I want to put some modern, I don't know, Node.js, JavaScript, mobile app on top that prefers JSON data. My developers are asking me they need now a JSON database. No, wait, hold on. We still have our good Oracle database. This is my relational application. It works like a charm. It's perfect. And I want to get consistent JSON results, and I don't want to generate them outside the database in Java code, because then it could be stale, etc. I just want to generate this in the database, maybe within my transaction or as a result of a join. And that's very easy. All you do is you write some SQL, the way you would do it for 30 years, and then you put some JSON generation functions on top. So what we want to do here in this example is we want to create a JSON object where the keys are the department in which our employees are working. So we want to have a key accounting and a key research, a key sales, and the value should be a list or a JSON arrays of all the employees that work in that department. So what I do is I first select from my department table using this JSON object ag function, aggregate function. It just generates one output out of these many rows. We will get one JSON object out. And the department name is the key. So this D name here generates accounting and research. Now, what is on the right side of the colon? What's the value? Well, that is now the result of a subquery. Now we query from our employee table where we join it with the department table on the department number. So every employee works in a department. And I create an array with all the people working in there. In this case, I only pick the name of an employee. So this JSON curly brackets that generates this JSON object. And I could have chosen different representations, maybe different rows for departments or one row for each input. It's just a matter of how you combine these SQL generation operations. Good. There's a lot of features that I'm not able to cover here. Just mentioning them here. So the message is if you're a DBA or someone who has experience with Oracle, say an architect DBA, that kind of person, you probably have a lot of skills and knowledge with it. And all of that applies with JSON. So we have made sure that all important features like partitioning or materialized view, Exadata in memory, that they all not only support JSON, but often are also have their own optimized code path for JSON. So if there's a use case where you think partitioning may make sense, well, you can partition on JSON data. We're able to extract the keys out of it. Or materialized view with JSON table, that's something we see quite often. We have indexes for JSON. There's all these security capabilities that Oracle has that can also be applied on JSON. I showed how you can map relational and JSON. There is a similar possibility with GeoJSON to our spatial data types. There's a one-to-one mapping in both directions possible. And this is where we see, this is really the converged database story, that the Oracle database supports multiple data models. Not only does it support them, but it also allows you to combine them, have a join across a JSON and XML and maybe a spatial object. So with 20C, or 20C was a preview release, but now in 21C, which is just around the corner, I guess, you will also get a JSON data type. I will show that in a second. And there is a new transform or update operator that was also backported to 19. And let's take a look at this actually here. So again, I'm showing this on a 21 database, and I just want to compare the textual JSON storage. So here I store it in a blob. These are the UTF-8 JSON bytes in a blob, and I add this check constraint on top. And I also want to try out this new JSON data type. So all I do is I say this column is a JSON. Now, if I describe it, you see test column is JSON, and this is really using a binary storage. So it's not, doesn't need the text parsing, and it is optimized for faster queries and also for updates that we don't have to basically to minimize the logs during updates. So now I need to generate some JSON. And instead of coming up with some sample data here, I was just lazy. I'm just using one of these views to, and then the JSON generation functions to generate me some sample data. So I'm using the CDB object. Doesn't really matter what the view is. It is just like some 70,000 columns in there. And all I do is I put this JSON constructor on top. I want to convert this to a JSON object. And this also already generates this JSON type, which right now I can't print in this SQL developer version here. I haven't downloaded the latest version. So this is why I put a JSON serialize on top to convert it back to a text to make it printable. So you see here, I got like a lot of different JSON objects. And what I want to do is I combine them in a big array. So now this gives me back one very large array with all these different JSONs. And what I do then is I insert this into my tables. This is the JSON one, and I insert the same one into my text one. And by the way, this is a demo, things could go wrong. Okay, so one thing we could do is we can see, well, what is the length? So how long are my text JSONs? They're like almost 13 megabytes. So again, it's one big document. And the binary JSON type has about 8 megabytes. So the main reason for this, and this is why I picked this big array, is that we do not store these repeating key names. So if you look at the this output here, you see that for every of these objects, it's quite repetitive. There is some data, but there are also long key names, and in the text version, they would need to get repeated, whereas in the binary format, we do have a hash map that replaces this with ID, so we can do faster lookups. Okay, all I do here is I increase the size a bit so that these time measurements that I want to do now make sense, because it was, even though this was on my laptop, it was very fast. So now let's say there was one field here, which is called flags, and I want to find out the maximum value. And on my text data, this takes about a second. Let's take a look at this JSON data type. It's probably faster, yes. I mean, these numbers are, this is on Docker. and the data is relatively small, so we're measuring sub-second times here, but on average, I'd say JSON type is about 3 to 5x faster. There's one example where it's a lot faster, and this is if you're looking for a field that doesn't exist. So in our text JSON, we have to scan through the entire data to find out that something is not existing, because there is no summary, and in an object, the keys are unordered. So if you look, for example, for an object with where middle name, you want to look for a middle name, and this object does not have a middle name, you have to parse it all the way to the end to find that out. There's no alphabetic order or any order in an object. But with the binary data type, we do have a summary or a header with all the existing field names. So in this example, we actually don't even have to look at the real data. All we have to do is look at the header to find out that X is not existing. And we can return right away. So what was this? 0.2 second versus 0.5 second. Yeah, the data is too small to really make sense, but good. So basically the message is JSON data type is faster while being a bit smaller. So this is good, we like that. There is one other aspect to show that. I create some JSON data using this dictionary view, and this has a field called time. And that data type is a date. And if you remember initially, I said JSON does not have a date or timestamp support, and that is correct. But let's do insert the JSON that we generate from this table. So what you see here is we have this spare, or these fields spare, we have a time, and now you see if you look at time, this looks like a string here, although it was a date in the original view. So what happens if we actually query, or if we ask what the data type is? So I have these, this is the simple syntax. So this is my table alias. I go to my column, and then I go to this field called time. So this is a field in my JSON, but instead of returning the value of it, I want to find out its type. And this is actually saying this is a date. So this is because in the JSON, in our binary JSON data type, we do preserve, let me quit my Slack, this is getting annoying. We do preserve these data types that JSON itself does not support. So JSON is only string, number, Boolean, null. And we have a lot more also different numeric types that we support in the JSON data type. You could also use the JSON value syntax with a long syntax $.time.type that does the same. If I remove this, we probably see the value again that we got extracted. So although this, so if we serialize this is now when we convert our binary representation to a string. So this does the conversion here from a date, which is not supported, to a string. So why do we preserve these types? Well, it's easy. If you use a client like Java, which has support for date, and then you can directly consume this JSON type and have a lossless mapping from the binary JSON to your Java date or Java timestamp, for example. It's only if you need to have this serialization into a string that you lose that type information. So at this point, if you receive this, you wouldn't know whether this came from a string or from a date. So this is a lossy conversion at this point. Well, let's do some updates on this one. This is this new update operator. It's very similar to the other SQL JSON operators in the sense that it takes the input. This is annoying here. Let's move this out. And then I say I have some operations like set, so I can overwrite the time with the current sysdate. Now we do JSON serialize, and we see that the time has been updated. And I can do more than just one operation. So here I set the time to the sysdate, then I rename the time, which is uppercase to lowercase, and I remove this field spare1. So I have a list of update operations that I can combine, and they're actually executed in exactly this order. So if I have, for example, a step that creates an object, I could populate the step in the next operations. And if we look at this, well, if we look at the end here, again, in an object, there is no order, so it's somewhere inside, but the time, you see this is now lowercase, and the spare1 should be gone. And the other possibility, I mean, this has like a handful of operations, also append for array operations, but it also has like a keep operation where you say delete everything, but in this case, I only want to keep the, oh, get an error here, that's not good. Interesting, that didn't happen while I practice. As I said, this is a demo. And this is just not a final label. So yeah, can't show this, but what it would do here, it is just preserving those fields that you actually want to keep. So for example, you would probably use this not to update your data because then it would really be lost, but you could use this JSON transform in a select statement if you want to ship some data from the database to a client, but you want to remove something transiently, not on disk, but on the way out to the client. You could just say what you want to keep here. Good, I need to look into this one. It's probably fixed by now, I hope so. Anyways, let's quickly go to the slides. Nobody's seen this. And with this, we're gonna go to, actually we can jump straight at the cloud offering, what we have. Okay, so I already said it, this feature has been available for quite a while. Was the first JSON database, I think 12.102 in 2014. And now with 19, we have added a lot more features. So 19 is a much more powerful release than 12.102 or 12.2, and 21C is coming very soon. And we also have added these cloud services. So if you go to, I'll just log in again. And by the way, I'm using the, I've signed up here with the Oracle Cloud with my private email, so I'm using this always free account. You can do the same. So if you want to get hands on the cloud, very easy, just sign up. And there is a new service called Autonomous JSON Database. That's a subset of autonomous transaction processing. And it's grayed out here because it's not yet available in the always free tier. I was told it's happening soon. But as it is a subset of autonomous transaction processing, I can show everything that autonomous JSON database can do in this free autonomous transaction processing. And if you click on this, and there is a tool called SQL Developer Web, and that allows you to play with SQL as well as with Soda. And I want to show you a bit about like a converged database use case. So let's move this side by side. So let's say we want to model a school. So a school has teachers, students, and courses. So in a NoSQL database or in a JSON database that would not support joins very well, we've seen examples where schemas mix different entities where for example, they say, well, I don't have any joins. So if I want to have, if I want to know, for example, what teachers are giving courses, I have to mix these in the same JSON hierarchy, and that generally creates a lot of problems. So with Oracle, you can really combine the best of the relational world, like foreign keys, primary keys, constraints, integrity, etc., while still getting the flexibility from JSON. And this is an example where we show this using like a simple schema for, let's say, a university or a school. So I start with my teachers table. Very simple. It's actually here, it's plain relational. Does not make any use of JSON. And so I'm inserting my teachers and I give them some IDs. So this is like from moon landing presentation. So we have these astronauts. And this is now like a plain relational table. But what we can do, if for whatever reasons we want the result to be returned in JSON, all we do is we put this JSON object constructor on top, or this generation function, and what we get back is a JSON object for each row. Good. So now let's look at the second use case. This is our courses table. And here with courses, we mix JSON and relational. So I have a bunch of relational attributes. And then I say, and again, this is what we see a lot of customers doing, is they say, well, I don't know. What I know is that my application is going to change. And for agility reasons, I don't want to always add my relational application or add columns to it. So I add like a flex column here. And here I don't use JSON type or anything. I just use club with a check constraint. And then we say, okay, maybe in my first insert, so here the flex field is null. So I don't know, this is fine. But then let's say after a while, I realize, okay, there is a schema change. I realize that a course can have a maximum amount of students. So instead of adding like a column for max students, I just put it in the JSON. And then let's say after a while, I realized like some courses could also be given in different languages. And I add another field here, language. But see, this is actually an array. So I have a cardinality that is different than 1. Good. So now if we select from our courses, I have to watch the time, but I think we're good. If I select from the courses.
You're good, Beda. 5 minutes to go and probably perfect. A bit more.
Yeah. So you see, if I select from my courses, I see this mixture of relational and JSON. So here's the max students. So how can I look inside? Well, I can just use simple dot notation. So on my flex column, I use this max students and I extract this value out. So I get a null value for those where it does not exist. And for the others, I get it. Now, how does this work with a language? Well, I could obviously just select the language here that works. I get back this array. So I have all the information, but it's hard to do like a search on this one. Let's say I wanted to find out all the courses that are taught in Spanish or Schweizerdeutsch, then I couldn't do an equality comparison with this column. I want to have this as a separate value. So now I need to unnest it. I have to go over my array, and this is our shorter version of JSON table. Uses this nested clause. So what I do is I go to my language array, I iterate over it like in JSON table and extract the value as a new column called language. And now you see here is English and Schweizerdeutsch. And now I could do a comparison. What you see here obviously is that there are rows being generated for each language. I see that these other values are being repeated. So the ID is seen twice here. Good. So this is this flex field use case. So now we have teachers, we have courses, and now let's say I want to do students. And here we jump all the way to collections. So instead of creating a table with columns and data types that I need to specify, here I'm saying all I want to do is I want to have a collection, like a bag of JSON documents, and I call this student. So under the cover, this will create a table where I store my JSON in a specified column, which I don't have to list. There is an ID associated with it, so I can do fast lookups by ID, and some additional data when stuff got created and when not. So let's run some insert statements here. So this is now the simple API where I don't have to write any SQL. Instead, I use these soda commands. So soda insert is one. And this is just in SQL CL here. And normally you would do this directly from your programming language. So there are equivalent calls from Java or Node, JS or Python, REST, where you can do these simple operations. And if I want to find something on it, I could, for example, use this pattern or this filter language to evaluate a filter on my collection. Basically, I want to look for all the documents that have a field called ID and the value being 2. I get this one back. This is actually not, the database does not see this. This is getting rewritten to SQL. All these soda operations, let's say soda insert, soda create, soda get, etc. This is just like a veneer, a convenience function on top of the database. All of these get rewritten to equivalent SQL. And the syntax, we call this query by example. This is something that NoSQL databases kind of came up with. It's kind of a JSON template that you match against your JSON document. So here we are looking for all the students who are enrolled in course C2. And you see Catherine Roberts is enrolled. Her course value is C1, not C2, but C1. But here you actually see with John Blaha, it's the value for courses contains C1. So it's not an equality, it's like an exist condition. So basically look for all the courses where the course C1 exists. This is why the cardinality change does not really make a difference when you query it. So you can query singletons and multiple values with the same query. Good, almost done here. So since this is stored as a table, the collection is a table, a system generate table, I can also use SQL to query it. So I'm using a JSON serialize on top of this JSON document, and the table name is the same as the course name. I can also run JSON table over it. So here I want to unnest all the courses. So I see, for example, I iterate over this course array and I see all these different courses for every student, like John Blaha takes course 1 and course 2. So I have now converted this to a relational view. And with this, if I use the same statement here in the with clause, I can do joins over my teachers tables, my student table, and my courses table, and I can very easily find out who are all the teachers of a given student. So I want to find out all the teachers for the student journey, and what I find out is that it's Jean Kranz. So this is really to show you that JSON and relational can really be mixed. It's not an either or. With this FlexFill use case, you can, it's like a slider. You can say I want to have 0% JSON or 100% JSON with soda or anything in between. Almost done, just last slides. This is how this soda stuff would look like from Java. So you basically get a connection to your database and you can create or open a collection, and then you have these simple statements like a simple insert or a filter, all the stuff I've shown here. We don't have to go into details. This is just for developers who like that experience and who maybe have learned that using MongoDB. And our message is pretty clear that it's the same concept that you can get in Soda. It may be syntactically different. So they called something parse and we call it create document from string. But conceptually, it's very easy to migrate from MongoDB to Oracle. And that summarizes our message. We have JSON in the database. You get all the power of SQL for reporting. And with Soda, you get this, this API for agile development, which is available in a lot of languages. So we were identified as the leader in this translytical data platform analysis. Those are databases that are not only transactional stores or not only analytical like warehouses, but a combination of both. Like you run your transactional workload while you also run some analytical queries. And we're very happy that our mission was identified as kind of the leading product. So yeah, if you like this, you can always contact me if you want more information. I recommend you maybe want to sign up on the cloud, try this out. On this blog here, these soda examples at the bottom. This is like an introduction to our cloud service. So the other interesting aspect is if developers want to compare it with MongoDB, we've shown actually that we're faster than they are on the same hardware. So this myth that NoSQL is faster because they gave up joins and transaction, all that is actually not true. Oracle is faster while still being with asset transactions and join and all the good SQL stuff. So MongoDB published a benchmark to show that they are faster than DocumentDB, and we were able to replicate the same benchmark on the same hardware, and we're like 2x or 3x faster. In the cloud, we're actually cheaper than MongoDB service. So the reason is this autonomous JSON database is the same as the transaction processing, but I think it's offered with like a 75% discount. So you get an ATP for 25% of the cost. And the reason is that, or you can't just move your relational workloads on there. It's kind of measuring how much JSON do you have, how much relational you have. So it needs to be like a JSON use case. Yeah, I can put this in the chat here, and there are some soda examples, like how to get started and some examples here. So let me just put this in the chat. And with this, I am pretty much done, and I can answer your questions now.
Thanks, Beda. I think that was a very comprehensive session on this subject. There was, of course, 2 questions. Gansho, who you might know well, raised the question on, hey, what's the preferred column type for the JSON data? Should it be in this kind of order saying, oh, JSON binary followed by blob, CLOB, and varchar? What about the main difference between the new JSON type that we've seen and blob? What is it that makes it different, and why should we have it?
Yes, I think so. First of all, the JSON binary data type will be limited to 32 megabyte in size. That does not really have technical reasons. It's more that we don't want to encourage people storing very large JSONs. And the main reason is that if you want to index something, the granularity of the index is the row. So if your index points at something that's like 100 megabyte large, then you still have to go through the 100 megabyte and find what you really want. So we want to encourage people to not store humongous JSONs, which most people get anyway. So that's most on average, there are a few kilobytes, 20, 30 kilobytes. So that's the first thing. JSON binary type will be limited to 32 megabyte, but it's not really a limitation. It is not storing JSON as a text. It's really doing a conversion to a binary encoding. So it's, I think for 80% of the use cases, it is much faster, but you have to pay the conversion cost. So if all you want to do is store some JSONs, and then send it as a reply to a REST call, and you want the JSON to be a text as a REST result, you may still want to store it in the textual representation. So varchar 32K is perfect if you know that everything fits inside. Often we see customers having outliers, like the average data being 5K or 8K, but then outliers 100K. So varchar 32K cannot be used because the outliers don't fit. And then you would use blob. There is not really a good reason to use CLOB at all. The reason is that CLOBs typically are twice the size because they use a UTF-16 or UCS2 encoding versus JSON is UTF-8. This is the variable width character set. So every ASCII character takes 1 byte in JSON binary type or in blob, but it would take 2 bytes in a CLOB, right? So the order would be it's not bad what you got on there, but I would say JSON binary tape first. If you want to really query it, then I would put varchar2, but most of the time it doesn't fit, then blob and kind of never clob. What's the major difference between the new JSON type and blob? So basically, if you look at a JSON text, you have a stream, or you have a serialized version of a tree, meaning you have these key value pairs, and even if a key is used very often, it's really repeated all the time. So what we did in this binary data type, we separate the content or the JSON into three different structures. There's a header, which lists out all the possible key names and gives them an ID. So like a long key name may just get the ID 13. So this gives some compression. Then we have the structure, and the structure has offset to the values, which are at the end. That's the third form. So this makes, for example, queries much faster because we just go to the value at the end. We can jump to the value. It also makes updates faster because we can just do an update in this value bucket or in the value part of this JSON data type. So they are very different. Like this binary type is not similar at all to a normal text JSON.
Thank you very much, Beda.
Yeah.
I must say, without having that recorded, it would be really to take notes. It's that much.
Yes.
Cool, great. Thank you very much. In 5 minutes, we start the next session. So before we do this, I just want to show you something which you might start to live very, very soon. I share my screen for a moment to show you something which is really something new and should be new for you. If you open up any of your browsers, you should see the Swiss Oracle User Group's website. But you could also go to your favorite search machine. In my case, it's a different one than the standard. And then you just check for one thing, for live labs, just to give you an idea on what you can do today in the cloud without any hassle to run through cool workshops. These workshops are there for everyone, and if you just check the JSON data stuff, you'll see there's a few things for you prepared, ready-made for free. Doesn't take a dime, doesn't take special presentation skills of anyone. You can use it at any time you want. And I think these kind of workshops can help you too. Yeah. It can also help you to bridge between you either being in a data management or DBA role with developers, because there's something you can watch together. Plus you can learn together. Having said that, JSON and Soda, they are for sure the big developer productivity keys, and you should use that. So with that, I think we close the recording for now and have a little break until we start the next session.